In this section, I'm going to talk about three other probability concepts, and those concepts will be calculating the probability of a union, the probability of a complement, and actually how odds relates to probability. On the first video, we're going to start with the probability of a union. So let's talk about the probability of the set A union set B. Now actually you can derive this straight from the addition principle. You might notice, remember the addition principle said the number of elements in A union B is the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. Well, it turns out that this addition principle also is the same concept for probability. So you can read the explanation on how I got the formula for the probability of A union B, but I'm not too concerned about developing it for you. I just want you to see that this is the formula that you can use. So it's just like the addition principle for counting, except this is for probabilities. So the probability of a set A union B is the probability of set A plus the probability of set B minus the probability of A intersect B. Now if A and B do not have an intersection, then just like that counting property, then you don't have to subtract off the A intersect B portion. You can just say the probability of A union B is the probability of A plus the probability of B. So those are the formulas that we're going to use here. So let me start you out with some simple examples. Suppose we select a single card from a deck of cards. Let's find the probability that we get a card that is a queen or a club. Now the or there to me is a red flag that identifies as the union. So I'm going to let A represent the set of all queens, and we know there's 4 queens in a deck. I'm going to let B represent the set of all clubs, and we know there's 13 clubs in a deck. And then I'm going to let A intersect B represent the set of cards that are both queens and clubs. Well, there's only one of those in a deck, and that would be the queen of clubs right here. So now to calculate the probability of getting a queen would be 4 out of 52. The probability of getting a club would be 13 out of 52. And the probability of getting a card that's in both groups simultaneously would be 1 out of 52. So if we add these two together and then subtract 1 out of 52, we actually get 16 out of 52, which reduces to 4/13. Now, the second one sort of shows you what happens if there is no intersection. So this one says the probability that we get a card that is a queen or a king that is selected. Well, we know there's 4 queens in a deck, we know there's 4 kings in a deck, and we know there's no card in the intersection. So there's no card that's a king and a queen simultaneously. So in this case, we can just add the probabilities of the two events. So we would get 4 out of 52 plus 4 out of 52, which is 8 out of 52, or 2/13. Let's take a look at another example. Suppose a single 6-sided die is tossed. Find the probability that the die lands odd or divisible by 3. So let A represent odd numbers, and you know there's 3 ways you can get an odd number if you toss a die, because you can roll a 1 or 3 or 5. And let B represent all numbers divisible by 3. And there's 2 numbers that you can get that are divisible by 3, and that would be a 3 or a 6. So there's 2 of those. And then we want to find how many are odd and divisible by 3. Well, there's only one of those. That would just be the number 3. So the number 3 is the only number we can roll that's both. So we would have one of those. So now the probability of getting A or B, A union B, would be the probability of A, which is 3 out of 6, plus the probability of B, which is 2 out of 6, minus the probability of the intersection, which is 1 out of 6, and this is 4/6 or 2/3. Now this one's a little bit silly. The probability that the die lands odd or even, you probably can already figure out that that probability has to be 1, because if you toss a die, it's got to land odd or even. But let's just look at it via the formula. There are 3 ways that it can land odd, there's 3 ways it can land even, and there's no ways that it can land both. So since the intersection is empty, I can just say the probability of A union B is 3 out of 6 plus 3 out of 6, which equals 1. This next example is a little more complicated. 2 cards are selected from a standard deck. What's the probability that you get a face card or an ace? Well, let's let A be the event you get a face card in the 2 cards, and B the event you get an ace in the 2 cards. So what we need to do is find the probability of A, find the probability of B, and then find the probability of A intersect B. So let's talk about the probability of A. So to get a face card, you actually can get a face card if you get at least 1 face card. So we need to figure out how many ways you can get 1 face cards or 2 face cards, because either way you would have a face card. So the number of ways to get 1 face card would be out of the 12 face cards choose 1, and out of the 40 non-face cards choose 1. And then we want to add to that the number of ways to get 2 face cards. So that would mean out of the 12 face cards choose 2, and out of the 40 non-face cards choose none. And if you add these together, you get 546. And then you divide that by the total number of 2 card hands, which is 52 choose 2, or 1326. So that probability would be 546 out of 1326. Then secondly, we need to know how many ways you can get at least 1 ace. So we calculate the number of ways to get 1 ace, which would be out of 4 aces choose 1, and 48 non-aces choose 1, plus the number of ways that you can get 2 aces, so that would be out of the 4 aces choose 2, and then 48 non-aces choose none, and you get 198. So the probability of B, that should say B, so again that should say the probability of B is 198 out of the same denominator, 52 choose 2, which is 198 out of 1326. Now we need to find the probability of getting both simultaneously. So in other words, of getting a face card and an ace. So the probability of getting, or the number of ways to get a hand that has a face card and an ace would mean out of the 4 aces you would choose 1, and out of the 12 face cards you would choose 1. So there's 48 ways out of 1326 that you could get a hand that has an ace and a face card. And now we just apply the formula. The probability of A was 546 out of 1326, the probability of B was 198 out of 1326, and the probability of A intersect B was 48 out of 1326. So if we add these together and then subtract the 48, we get 696 out of 1326, which is 0.5245. I have a couple more problems here. This one says find the probability of 2 dice being rolled and them being the same number or a sum greater than 8. So really here all you have to do is find the probability that they're the same number, and there's 6 ways they can be the same number out of 36. Then find the probability that the sum is greater than 8. So just list all the ways you can get a sum greater than 8, and you'll see there's 10 out of 36 ways. And then subtract from that the probability of both events occurring, and there's only 2 ways that both events can occur. You can roll a 5-5 and a 6-6, and that'll give you that the dice are the same number and greater than 8. So that probability would be 2 out of 36. So add these 2 together and then subtract the 2 out of 36 to get let's see, that should actually be 14 out of 36. Let me correct. So as I said, that should be 14 out of 36. And if you reduce that, you get 7 out of 18. Okay. Now, the next one is real similar. Why don't you just pause the video and read this one? But as you read it, you'll see that on this one, I wanted the probability the first die is a 2 and the event of a sum of 6 or 7. So I found there were 6 ways out of 36 to get 2 on the first die. There's 11 ways out of 36 to get a sum of 6 or 7. And then there's 2 ways out of 36 to get a 2 on the first die and get a sum of 6 or 7. And then so I just added these two and subtracted this to get the answer. The next one says the sum of the results is 11 or the second die is 5. Well, there's 2 ways to get a sum of 11, so that's 2 out of 36 is the probability. There's 6 ways to get a second die to be a 5, so that would be 6 out of 36. And then there's 1 way that both of these can happen. So the only way to get a sum of 11 and the second die is a 5 is to roll where the first die is a 6 and the second die is a 5. And so that's only 1 way out of 36. So if you combine these, you get 7 out of 36. And then the last one says the sum of the results is 11 or the second die is 3. Well, on this one, there's 2 ways to get a sum of 11. There's 6 ways to get the second die is 3, but there's no way that you can get both of those simultaneously. So in that case, you would just add the 2 probabilities together, 2 out of 36 plus 6 out of 36, which is 8 out of 36, which reduces to 2/9. Okay, I want to finish with an interesting union formula problem. Suppose a number is randomly generated from 1 to 1,000. What is the probability the number is divisible by 3 or 7? Well, we know the number in the sample space is 1,000 because there's 1,000 numbers we could get. Let's let A be the event it's divisible by 3 and B be the event it's divisible by 7. So what I want to know the probability that the number is divisible by 3 or divisible by 7. So I'm really looking for the probability of A union B. So what I need is the probability that a number is divisible by 3, and I need the probability that a number is divisible by 7, and I also need the probability that a number is divisible by 3 and 7. Well, to figure out how many numbers are divisible by 3 from the first 1,000 numbers, just divide 3 into 1,000, and you'll get that you get 333 for the quotient and a remainder, but we don't need the remainder because this tells us there's 333 numbers divisible by 3. So the probability that a number is divisible by 3 is 333 out of 1,000. Now, for the probability a number is divisible by 7, divide 7 into 1,000, and you get 142. And again, drop the remainder, and you know there's 142 numbers divisible by 7. Now, in order to determine all the numbers that are divisible by both 3 and 7, you actually need the smallest number that both 3 and 7 will go into, and that would be 21. Because if 21 will divide into 1,000, then 3 and 7 would both also divide into 1,000. So divide 21 into 1,000, and you get 47 whole numbers. And so that would tell me that the probability of the number is divisible by 21, in other words, divisible by both 3 and 7, that probability would be 47 out of 1,000. And then if you add these 3 numbers together, and well, actually you add and then subtract this one, you get 428 out of 1,000, or 0.428. In the next video, we'll talk about how to find the probability of a complement.